Calculus, video 82, the area of a region with respect to x and with respect to y. So what we're going to do here is we're going to take a region, and we're going to first find the area with respect to x, right? So with respect to x means we have x bounds, top function, minus bottom function, the integral of that dx. And we'll get an answer. And then we'll take the same region, but we'll think about this in terms of y, or with respect to y. So we'll get y bounds, right function minus left function, the integral of that, dy. And we should get the same area. It is the same region after all. So let's first try that of the region with respect to x. So number one, determine the area of the region bounded by y equals 2x plus 2 and y equals x plus 1 squared with respect to x. Again, let's try a picture here. Y equals 2x plus 2, that's a slope of 2 with a y-intercept of 2, so something kind of like this. And then y equals x plus 1 squared. That is a parabola that has been moved to the left by 1, and so something like this. And we want the area of the region bounded by these curves. So we are looking for this region in orange right here. The first thing we want to do is find the bounds. Now we're doing this with respect to x, so I want x bounds. And my x bounds are going to be, say, this intersection point here, let's call that A, and this intersection point up here, let's call that B. Those will be my x bounds. I can see that my top function is going to be that blue line, 2x plus 2, and my bottom function is going to be x plus 1 squared. I'll have top function minus bottom function, x bounds, integrate that with respect to dx. In order to find the bounds, recall that we set the functions equal to each other. 2x plus 2 is equal to x plus 1 squared, and we solve for x. Now, in this case, I think what I'll do is I'll take that x plus 1 squared, and I'll go ahead and multiply that out as x plus 1 times x plus 1. So 2x plus 2 is equal to x plus 1 times x plus 1, like so. Distribute, and I get 2x plus 2 is equal to x squared plus 2x plus 1 when I multiply all that out. And now that I have a quadratic, I'll move everything to one side. So we'll subtract the 2x, we'll subtract the 2, and we end up with 0 on the left-hand side, and x squared. 2x minus 2x is just 0, 1 minus 2 is negative 1, and we end up with 0 is equal to x squared minus 1. Solving, I think I'll go ahead and put the 1 back over to the other side, get x squared is equal to 1, take the square root of both sides, and don't forget that would be plus or minus the square root of 1, that is plus or minus 1. So it looks like my x bounds here has a left bound of negative 1 and a right bound of positive 1. So I'm going to replace a and b down here with negative 1 and positive 1. So to find the area, it'll be the top curve minus the bottom curve, the integral of that from negative 1 to 1 dx. Area is equal to the integral negative 1 to 1. Top curve, 2x plus 2, minus bottom curve, x plus 1 squared dx. And once again, x plus 1 squared could be an interesting integral. But for right now, let's just go ahead and multiply that out. X plus 1 squared going back over here is x squared plus 2x plus 1. And so I'm going to write this as the integral from negative 1 to 1, 2x plus 2, minus parentheses x squared plus 2x plus 1 dx. That is the integral from negative 1 to 1 of 2x plus 2 minus x squared minus 2x minus 1 dx. We once again see the 2x's canceled, 2x and negative 2x, and we get the integral from negative 1 to 1 of negative x squared positive 2, negative 1 is plus 1 dx. Now, had you done the curves backwards, had you done x squared plus 2x plus 1 minus 2x plus 2, we would have got the exact same thing here, except the signs would have been switched. You would have had x squared minus 1 as opposed to negative x squared plus 1, and that will lead you to a negative area. And we know that the area of a region will always be positive. Okay, so moving forward, we have negative 1/3 x cubed plus x from negative 1 to 1. That would be negative 1/3 times 1 cubed plus 1 minus negative 1/3 times negative 1 cubed plus negative 1, or just minus 1. So I get negative 1/3 plus 1 minus. Okay, so negative 1 cubed is negative 1 times negative 1/3 is positive 1/3 minus 1. That would be, let's see, negative 1/3 and negative 1/3 is negative 2/3. 1 minus negative 1 is 2. And so 2 minus 2/3 would be 4/3. We should be getting area of 4/3 or 1 1/3 or 1.33 for this region in orange here. All right, so that would be finding the area of the region with respect to x. Top curve minus bottom curve, x bounds dx. Same problem, but now let's do this with respect to y. Let's see if I can copy and paste here. Determine the area of the region bounded by, mostly got it, y equals 2x plus 2 and y equals x plus 1 squared. Now, with respect to y. If we're going to integrate this with respect to y, it means that my equations must be in terms of y. Right? So that way I can have y bounds, equations in terms of y, and dy. In order to get my equations in terms of y, I need to solve for x in each of these equations and have, instead of y equals 2x plus 2, I need to have x equals something in terms of y. Same thing for the other equation as well. The picture, however, really doesn't change because the graphs are the same. We still get this parabola that comes down at negative 1 and then comes back up. And we still get this y equals 2x plus 2 here for the region, which is try to draw the same thing, but not exactly. Okay. Same intersection points, only now the intersection points aren't going to be for the x-axis because I want this with respect to y. I want intersection points on the y-axis. It's this a value and this b value, from that point there to that point there on the y-axis. So my a to b here are y bounds. And I need to turn both of my equations into x equals something with respect to y, or in terms of y. So let's do that here. Y equals 2x plus 2. We'll get the bounds in a second. Let's solve for x. Solve for x. So I want to subtract 2. Y minus 2 is equal to 2x. Divide by 2. 1/2 times y minus 2 is equal to x. In other words, x is equal to 1/2 y, distributing the 1/2 to both terms here, and then minus 1. Something like that. Okay, so there's the first one. And you want to keep them straight because y equals 2x plus 2 is the line. Right? This turned into x equals 1/2 y minus 1. That's still the line. But it was the top function, but now we're doing left and right functions, right? And in terms of left and right functions, or right and left function, the green curve is the right function, the red line is the left function. So the 1/2 y minus 1 turns out to be the left function. Okay, let's do the next one. y equals x plus 1 squared. Solve for x. I'm going to start by square rooting both sides, and I get plus or minus the square root of y is equal to x plus 1. Now, we have plus or minus the square root of y. What's happening here is the parabola turns into a plus or minus square root. The right arm, or the right curve of the parabola is the positive square root of y. The left curve of the parabola is negative square root of y. The region we're talking about is the right curve of the parabola, and so we can just use the positive square root of y here, not plus or minus. Solving for x, I get x is equal to the square root of y minus 1. Right, so that would be this right here, this green curve, x equals square root of y minus 1. And that ends up being my right curve. And so now we can do area is equal to the integral from a to b y bounds this time, here and here, of the right curve minus the left curve dy. Okay, well, what are those bounds? Now, I could kind of look at it and think, okay, I think the a bound, the lower bound here is 0, and the upper bound is well, we're not sure. Okay, so what we do is we set the equations equal to each other. So to get bounds, I have this. My equations now are x equals square root of y minus 1. So I have root y minus 1 is going to be equal to 1/2 y minus 1. And if I add 1 to both sides, the 1's cancel, and I get root y equals 1/2 y. Let's move everything to one side, and so I get 0 is equal to 1/2 y minus root y. Factoring out a square root of y, 0 is equal to square root of y. That would be 1/2 root y minus 1. Separating these, zero factor property says that root y equals 0, and 1/2 root y minus 1 equals 0. Solving, I get y equals 0. There's one of the bounds. That's this lower bound a right here. Y equals 0. And then over here, 1/2 root y equals 1. Multiply by 2. Root y equals 2. Square both sides. Y equals 4. So the bounds here, the y bounds, I'm going to erase the a and b here, go from 0 to 4 of right curve minus left curve. It should look something like this. Area is equal to the integral from 0 to 4 of my right curve in terms of y. My right curve in terms of y is the square root of y minus 1. Minus my left curve. My left curve in terms of y is that line, x equals 1/2 y minus 1. So 1/2 y minus 1. Make sure you put that in parentheses. Right minus left dy on the y bounds 0 to 4. Okay, so that would be the integral from 0 to 4. Let's see if we can simplify. We have root y minus 1 minus 1/2 y, negative, negative, negative would be plus 1 dy. Those two cancel. Integral 0 to 4, root y minus 1/2 y dy. And root y is the same thing as y to the 1/2 power, so maybe I'll rewrite that as y to the 1/2 power. Integrating here, we get y to the 3/2 power. Divided by 3/2 is the same thing as times by 2/3. Minus 1/2, I get y squared. Divided by 2 is the same thing as multiplying by 1/2. Evaluated from 0 to 4. So that's 2/3 y to the 3/2 minus 1/4 y squared from 0 to 4. Let's plug in the 4, let's plug in the 0, and hopefully we'll get the same answer that we got back when we evaluated this with respect to x. If you remember, that answer was 4/3. So hopefully we'll get the 4/3 again. Okay, when I plug in the 4, I get 2/3 times 4 to the 3/2 minus 1/4 times 4 squared minus, plug in the 0, we like that, that's just 0. Alright, 4 to the 3/2, the square root of 4 is 2, 2 cubed is 8, then 8 times 2 is 16, I get 16/3 minus 4 squared is 16, divided by 4 is 4. That would be 16/3, 4 becomes 12/3, 16 minus 12 is 4/3. Same answer whether we did this area with respect to y or respect to x. A couple notes here. If you're going to find the area with respect to y, make sure you are using y bounds, and also that you have rewritten your equation x equals in terms of y, and then do right minus left.